Hello. In this video, we're going to be doing question 14 on Machine Learning 2's Practice Final Written Exam for DS 4420. This question has to do with kernels. It asks, given a point x, its corresponding feature map, a function, and some points x0, x1, answer these 10 questions. So, there's 10 questions. We'll get started immediately. Question 1 asks, use the reproducing property, what is f of x0? So the reproducing property, if you remember, states that f of x equals the inner product of f and k of dot x. Or you might remember the form f, the inner product of f, and in this case, lowercase phi of x. So this is cool. So f of x0, it would follow then that this might be the inner product of f and phi of x0. Okay, so now we check. We are not given phi of x0, but we're given phi of x. So we can find phi of x0. Now we'll notice that x is of the form a is the first element, b is the second element, and c is the third element. Phi of x states that the first argument, or the first element, is AB. So it would be the first and the second element of whatever x matrix, x vector we have. Then we have C minus B, so we would have the third minus the second, and we have 1. So if we apply this logic to x0, where the first and second elements are 1, and the third element is 0, we get AB for the first one, which is 1, C minus B for the second element, which is 0 minus 1, so negative 1, and we have 1 for the third element. So we then take the inner product of, this is, f is 0, 1, 1, and we have our other one, 1, negative 1, 1, for reasons I just outlined above. And if we calculate this, we get, I believe the inner product of these is 0. All right, second one. What is the corresponding kernel function k of I, j, k of xi, xj? In this case, you might remember the slides. This is defined. Let me write this out more explicitly. K of xi, xj is equivalent to the inner product of phi of xi, x. There is no comma there, it is here. Cool. We don't know what xi and xj are, so we can't solve it any further. This is our answer to part 2. For part 3, we are asked, what is k of x0, xj, x1? Well, this we can calculate. I believe in this case, this is equivalent to little phi. So maybe I'll just rewrite these, actually. That is the wrong stylus. So k of x0, x1 is equivalent to the inner product of, and we found phi of x0, little phi of x0, so that's 1, negative 1, and 1. And similarly, if we use our formula to find phi of x1, we'll find that phi of x1 is AB, C minus B, so that would be 1 minus 0, so 1 and 1. So this is going to give us, again, 0. All right. Now, let's move along. Part 4. If k of xi, x1 equals 2, and xi equals 1, 2, p transpose, what is p? So we're going to need to apply our transformation here. So theta of xi is equivalent to And then we have a minus, or ab, so that would be 2. We have c minus b, so p minus 2, and we have 1. So this is phi of xi. It is 2 p minus 2 and 1. Okay, so knowing that, how do we calculate p from this? Well, we plug in our values and we'll get something that we can equate to 2, and then we can substitute it in. So let's do that. Xi and x1. 2 p minus 2 and 1. And this is x1, so it's going to be 0, 1, 1. I'm not doing great on the curves today. Oh my goodness. Okay. So 2 p minus 2 plus 1. So it's going to be p minus 1 equals 2. So p equals 3. All right. Moving along, if fa of x0 equals 4 and fa equals 0 p1 transpose, what is p? This is just saying the statement fa of x0. This is equivalent to the inner product of fa and phi of x0. This is using the reproducing property, right? Because you see how f of x0 is equivalent to the inner product of f and phi of x0. So we just plug in our new values, 0, p, 1, and we have, what is this, 1, negative 1, 1, I believe. So we get 1 minus p equals, and this is 4, right? Yes. Yes, 4. So then we have p equals negative 3. Okay, now let's move on to the next one, part 6. Given calculate f plus fa of x1. Okay, so let's do that. We would just add. So this would be f plus fa, and then x1 here, right? Yeah, x1. So this gives us inner product of 0, 1, 1. And we know fa is 0, p1, which is 0, negative 3, 1. And we know that this is a sum, and this is, I believe, x1 is 0, 1, 1. Yep, okay. So this is, what is this? 0, negative 2, and 2, and 0, 1, 1. So we get 0. Part 7. Ooh, 10 problems is a lot. Calculate, given x0, x1 as the only two samples, what is the big phi matrix? Oh, okay. So here, big phi is equivalent to phi 1, phi 2. Or, no, that's not the right notation. It's phi of x1, phi of x2. You can remember it as just the little phi's all make up the rows of the big phi. So we can just plug that in, and we get 1, negative 1, 1. Actually, x1 and x2 are the wrong numbers. It's x0 and x1. And these are the only two samples, as he stated, so this is going to be the entirety of phi. Okay? Moving on, number 8, we have What is the kernel matrix? So you can remember how to calculate the kernel matrix. K equals phi transpose. So that can just be 1, -1, 1, 0, 1, 1 times 1, -1, 1, 0, 1, 1. Doing a really bad job at aligning these. And this gets us, so 1 times 1, -1 times -1, 1, so we get 3. And then we have -1 and 1, so 0, 0, and we have 2. On the exam, if you're asked to do this, remember that a matrix with the transpose of itself, they will always be diagonal, or not diagonal, symmetrical, that's the word. Okay, now part 9. We have, what is the optimal function that fits the two samples, x1, x2, to y using kernel regression? Okay, we think about this. Yes, so it's just k times alpha equals y. So that would be 3002 times alpha 1, alpha 2, and y we're given is 62. So we have that alpha 1 equals 2, alpha 2 equals 1, so alpha equals 2, 1. And what is the Q matrix kernel PCA on these two samples? The solution is the eigenvector of the Q matrix. Calculate the Q matrix. Okay, so let's find the Q matrix. You might remember from kernel PCA that we substitute, what is it? Alpha transpose K centering matrix, K alpha, and then this portion is Q. So we have 3002. C is the centering matrix, so you might remember that as the identity minus 1 over n times a matrix of 1s that match the dimensions. 1 over n in this case, n is the number of samples. So this is minus 1 half 1, 1, 1, 1, 1, 0, 0, 1. So we have, this gives us 1 half times 1, -1, -1, 1. So then let me move this down a bit more. Q is not faded for starters. 3002 times 1 half, -1 half, -1 half times 3002. Now we gotta multiply these. So 3002. Okay, so this should give us 3 halves, -1, -3 halves, 1. Okay. And then, okay, then we do another round of multiplication. So, oh boy, 9 over 12, -3, 2, and -3, okay? So this is Q, and then the answer is the eigenvector of the Q matrix. So let's do some eigenvector. Okay, 9/2 minus lambda, 2 minus lambda, plus minus 9. So then we get 9, then should be 5. 9/2 negative. Four 2 is lambda, then plus lambda squared minus 9. So then we get lambda squared, right? Yeah. So then lambda squared minus 13/2 lambda. So we have lambda equals 0, and more lambda times lambda minus 13/2. So lambda equals 0, or 13/2. These are the two eigenvalues. And then we would plug these back in to get our eigenvectors. Right? So we should add to the Q matrix. Okay. So then plug these back in. Should make this more clear. I guess it is, yeah, in factorizable form. This would be 9/2, 6/2, 3, 2, negative, negative. This is lambda equals 0. I guess I'm doing this out of order. Lambda 2, lambda 1. There's two eigenvalues. I'm confused. Okay. Then we apply. So this is just like this times x1, x2 equals 0. So we would get x2 is 1.5 and x1 is 1. So 1 3/2. And this would be 13/2. The heck? So this would be -2, -3, -3, and the heck? -8.5, and that doesn't work. So this is the only eigenvector, and we could simplify this, which we probably should. So standardize it. So 1 plus 9/4. Make the magnitude. So root of this. So this is root of 13/4. So our answer would be 1 divided by root 13/4. And, right? Yeah. And then, was it 3/2 divided by root 13/4. That whole thing is. Okay, and then this is the answer to number 10. It's a bit longer. Okay, yeah, I'll just scroll down slowly from the top, and that was question 14. So, yep. All right, good luck on your studying.